Hello, this is Britt Caswell with another example video. In today's video, I'm covering example 5 from section 7-4 in the SavvasRealize Algebra 2 textbook. The goal of today's video is to compare key features of two periodic functions. Alright, so Savvas is giving us an equation and they're giving us a graph, and we're comparing those to kind of talk about what we see. Alright? So in this first part, it wants us to compare the period and the amplitude. I think the amplitude's easy, so I'm going to start with that, alright? Don't judge me. So my amplitude on my equation is the absolute value of the number being multiplied to the trig function. So my amplitude on this equation is a 4. Now if I think about my amplitude for my graph, notice that it goes from -4 to 4, so my midline is here at y equals 0. So this has an amplitude of 4 as well. Now, this graph feels upside down, right? Because on this graph, instead of going up like a sine function does, it goes down. Or if I'm comparing it as a cosine, it's undergone some kind of shift, hasn't it? Because the cosine starts here and then goes down. So there's been a phase shift. So understand, if I wanted to write this equation, I need to add or subtract something inside of the function. There it is. Anyway, so now let's talk about the period. So remember, the period is the amount of time that it takes to do one iteration of the process. So for a period for an equation, what I'm going to do is I'm going to take 2 pi and divide it by the b value, which is pi over 4. That's kind of ugly. We don't like a fraction divided by a fraction, so let's go ahead and change flip that. So I keep my 2 pi, change to multiplication, and flip pi over 4 to saying 4 over pi. So you can see my pi's cancel out and I'm left with an 8 for my period. I'm going to rewrite that down here because it's a little intensive there. Now on this one, what I recommend doing a lot of times with graphs is to go from peak to peak or trough to trough. Some people like to repeat the pattern, whatever. They give us some anchor points here at trough to trough, so I'm going to count on that. So this distance on the x-axis, it's going from 3 to 7, is 4. So this one has a period of 4. And you can see that from going from trough to trough, or peak to peak, whatever way you want to say it. So now let's talk about the frequency. So if I'm comparing the period here, okay, I'm going to say the equation and graph have the same amplitude, but the equation has twice the period of the graph, right? Because the equation has a period of 8 and the graph has a period of 4. Now let's talk about the frequencies. So if I'm looking at the frequency of the equation, right, the frequency is equal to 1 over the period. So this frequency is 1/8. So if I'm looking at the graph, the frequency is 1 over the period, so 1/4. So if I were to describe the frequencies between f and g, I would say the frequency of the equation is half of the frequency of the graph. And that kind of makes sense, right? So if a period is doubled and a frequency is the reciprocal of the period, it makes sense that it would be a half. Now the only other thing that's going to be different about these two functions is because their period is so different, that means that the length between these bounces is going to be different. And so this is going to change the x values, or the x-intercepts. So I'm going to say the x-intercepts of the functions would also be different. So there we have it, guys. There's some of the key features of two periodic functions and how to compare them. Until next time.